Types of numbers part 2. Here we have rational numbers. We have irrational numbers, we have real numbers, we have imaginary numbers, and we have complex numbers. Rational numbers. First on our list are rational numbers. Rational numbers are real numbers that can be expressed as fractions where both the numerator and the denominator are integers and the denominator is not 0. Some examples are 1 over 2, they are fractions 1 over 5, 3 over 4, 0 over 1. As said here, the denominator is not 0, so the numerator could be 0, but the denominator is not 0. That's the number on top of a fraction can be 0, but the number below, which is the denominator, cannot be 0. So you have 0 over 1, 0 over 2, and so on, be it a proper fraction or an improper fraction. So any number over 0 is not a rational number. So we can have it on top but not below. So 1 over 0 is not a rational number, 2 over 0 is not a rational number, and 3 over 0 is not a rational number. And also note that rational numbers can be converted to decimals, and they either form terminating decimals or repeating decimals. Examples of terminating decimals are 0.2, 0.25. These decimals end is like having 1 over 5, which is 0.2 when you convert from fraction to decimal, like 25 over 100 or 1 over 4. Those are terminating decimals, that they have an ending. Examples of repeating decimals as 1.2222. It doesn't come to an end, you keep going in twos. These are repeating decimals. They don't have endings, but they're always repeating. And you also have them in this form, 1.12121212, or we can have them in this form, 2.123123. They are repeating decimals. You see that 123 is being repeated, and in this place 1212 is being repeated, and here you have it in 222 being repeated. So these are examples of rational numbers. Irrational numbers, they are sets of real numbers that cannot be expressed in form of a fraction. Also, the decimal expansion of an irrational number is neither terminating nor repeating. It is contradicting to the rational numbers. Now means we don't have it as terminating like we just done while explaining rational numbers, or repeating where you have it as 1212. Here we have them as not ending, never ending. Examples of irrational numbers are 1. Pi. We know pi is 3.14159265, and so on. It continues, it's not ending. The decimal value never stops at any point, it continues. Although pi itself cannot be written as a fraction, but you've noticed that you always have it as 22 over 7, since this 22 over 7 is the closest value for it. Note that 22 over 7 is a rational number. Again, 22 over 7 is a rational number, but pi, which is represented by 22 over 7, is an irrational number. Also note, 22 over 7 is not the actual value of pi, but it is the closest fraction to the value of pi. Therefore, pi is not exactly 22 over 7. Irrational numbers cannot be expressed as real fractions, but for the sake of calculation and the closeness, pi is expressed as 22 over 7. It is often shortened as 3.14. Now, the world record for the number of digits of pi that have been calculated is 62.8 trillion. So we have 3.14159 and so on till you get to 62.8 trillion values or numbers behind the decimal. That's really huge. Another example of an irrational number is square root of 2. Square root of 2 is also irrational because you have it as 1.414213 and so on. Euler's number is also an example of an irrational number. It's a decimal with not terminating values. It continues and they are not repeated. We can see that they are not terminating, they don't have an end, they continue. Same as the golden ratio. You can see it continues, it doesn't end. These are all examples of irrational numbers where the decimals do not end or terminate. Real numbers. All forms of numbers except imaginary or complex numbers are regarded as real numbers. They include negative integers, 0, positive integers, decimals, and fractions. Examples are -2, 3, 0, 1.5, 3 over 2, root 5, and so on. Imaginary numbers. Now, next on the line is imaginary numbers. They are square root of negative numbers. Normally, you can't easily find the square root of a negative number using your calculator. For example, square root of -1. On this calculator, it's saying invalid input. But the square root of -1 at an advanced level is I, like we have I here. Square root of -1 is I, and the I is the imaginary number. So we can easily find the square root of negative numbers. The imaginary unit I is also known as the iota. For example, the square root of -4, this can also be written as -1 times 4, because -1 times 4 will give you -4. We can also rewrite it as square root of -1 times square root of 4. Square root of -1 is I, and square root of 4 is 2. So square root of -4 is 2I. This is at an advanced level where you do the square root of -4, but at your level, the square root of -4 is impossible. This I is the imaginary number, also known as the iota. So this is an imaginary number. Complex numbers. And last on our list is complex numbers. It is the sum of real numbers and imaginary numbers. And this is an example: 2 plus 3i. Like the definition says, it is the sum of real numbers and imaginary numbers. Like we have here, you have 2, this is a real number, plus 3i, this is an imaginary number, 3i. We have another example as -2 minus 5i. Although you have -5i here, it's still joined by addition.